Ever seen animal bones turn into drinking water pipes? Give me 1 minute and I'll show you how. One smart factory said, don't dump bones, use them. Let's follow the simple trip from bone to pipe. Trucks bring big cow and goat leg bones to the factory. Workers wash and weigh them. Only clean, solid bones stay. Water jets blast off all meat. The bones dry in a hot drum until crisp. Crushers snap them into chips. Fast grinders spin the chips into smooth bone powder, softer than flour. The powder is full of calcium. Mix 1 scoop of bone powder with 9 scoops of melted plastic. The mix looks like cookie dough, but acts like super glue. The hot blend pushes through 2 long screws and out a steel mold as a glowing tube. Cold sprays freeze the shape. Robots slice perfect 6-meter pieces and print bone pipe on each. Some pipes go to the lab. Machines pump water until they burst. Normal plastic splits early. Bone pipes bend first, so crews see trouble before flood. These pipes are stronger, lighter, and faster to install. Crews need fewer cranes, save fuel, and cut costs. The planet wins too. After 50 years, old pipes are shredded and heated. The plastic turns into fuel. The bone powder is cleaned and used again in fresh pipes. Bones to pipes. Ways to wonder. Like and subscribe for more smart recycling stories.
Ever wondered where your empty water bottle ends up? First, huge trucks pour mountains of used bottles onto a moving belt. Workers and smart cameras quickly sort out any metal, glass, or paper. Only clean plastic heads forward. This saves time, energy, and keeps the final product here. A row of roaring grinders chops the bottles into tiny flakes, like colorful confetti. The flakes dive into giant washing drums filled with hot, soapy water. Dirt, labels, and leftover soda float away, leaving shiny, clean plastic pieces. Next, the clean flakes slide into a long, hot tunnel called an extruder. Inside, spinning screws melt the plastic into thick goo. The goo squeezes out through tiny holes, cools instantly in water, and snaps into rice-sized pellets, perfect fuel for new products. Pellets shoot into a powerful injection molding machine. In seconds, liquid plastic fills a chair-shaped steel mold. The mold slams shut, cools, and opens, revealing a one-piece commode seat with built-in legs and lid. No screws needed. Robotic arms trim rough edges, while quality staff sit, press, and twist to test strength. Any weak chair gets recycled again. Nothing is wasted. And that's how yesterday's bottle becomes today's bathroom essential. Recycling symbol keep recycling. Ever wondered where your old copper pipes? Mountains of used copper arrive at the recycling yard. Everything from snap plumbing tubes to tangled electrical wire. Workers and magnets pull out steel screws and plastic bits because pure copper brings the highest price, while heavy copper granules drop into waiting bins, 99% clean without a single chemical added. Inside a rotary furnace blazing above 1,000 degrees Celsius, the granules swirl like liquid fire. Oxygen lances burn off the last traces of oil and paint. Within minutes, the metal becomes a glowing, lava-smooth pool. Operators tilt the furnace. Molten copper slides into graphite molds and cools into 200-kilogram pigs. Ingots re-enter a reheat oven, then squeezed through giant rolling mills, thinning from brick-thick slabs to coin-thin sheets. Some sheets feed a drawing machine that stretches them into hair-thin wire, ready for tomorrow's smartphones and EVs. Copper is infinitely recyclable. Almost 80% of all copper ever mined is still in use today. So the next time you recycle a copper scrap, remember, you're not throwing metal away. Have you ever stopped to wonder how a simple brush scrubs mud off your favorite jeans? Railcars unload pellets of recycled polypropylene for the handles, while bales of nylon and Tampico fiber wait for bristles. Moisture meters check each batch. Dry pellets and clean fibers mean fewer defects later. Orange hot plastic shoots into a steel mold shaped like a palm-friendly block. 40 seconds later, robotic arms pop out a perfectly formed handle still steaming from its 220 degrees Celsius berth. An air jet cools it, then a conveyor lines it up for drilling. A CNC head punches dozens of 4mm holes in less than 5 seconds. Precise spacing is key for even scrubbing. Another cutter carves a thin anchor groove around each hole. The groove will lock the bristles in place. Watch this sewing machine on steroids. It pulls a U-shaped loop of nylons. Next, a high-speed grinding wheel flags the tips, splitting each strand into tiny microfibers that grab dirt without scratching fabric. A hot stamp machine presses the company logo in silver foil onto the handle. Inspectors flex the bristles 10,000 times. Finish brushes slide into a paper sleeve made from 80% recycled pulp. Ever eaten off yesterday's shampoo bottle? Stick around, you'll see waste plastic reborn as shiny dinner plates. Only food-safe plastics, smart and move ahead. Clean feed equals safer plates. Rotating knives slice bottles and tubs into popcorn-sized flakes. The flakes dive into bubbling hot water with EcoSoap. Labels, glue, and ketchup residue float away, leaving bright food-grade plastic bits. Giant air tunnels blast the wet flakes dry. They tumble straight into an extruder, an extra-long, heated screw. Inside, flakes melt into smooth, syrupy plastic. The syrup squeezes through tiny holes, settles, cools, and snaps into rice-sized pellets, perfect recipe for new plates. Pellets drop into a high-speed thermoforming line. Sheets are heated until floppy, then slammed between mirror-smooth plate molds. Vacuum pulls every ridge tight, creating a flawless surface. In just 2 seconds, plate form. Laser blades kiss off the extra rim. Cameras inspect color, thickness, and strength. Any rejects re-enter the shredder, zero waste, endless loop. And that's how yesterday's plastic trash becomes today's dinnerware. Safe, strong, and dishwasher ready. Recycling symbol: eat smart, recycle smarter. Like and follow for more factory magic. Huge bins of mixed-grade steel scrap roll in. A powerful magnet lifts the metal and drops it onto a roaring conveyor. Inside the shredder, spinning hammers break the pieces small, while air jets blow away rust and dust. Clean chips travel up to a 1,800 degrees Celsius induction furnace. Melt together. 2 dies slam shut with 500 tons of force, flaring one end into the familiar mushroom head that locks against the tractor hitch. Excess flash is trimmed off by a ring cutter in the same stroke. No wasted motion. Onboard lasers measure every cut. Bad readings stop the line instantly. Pins ride through a controlled atmosphere furnace at 880 degrees Celsius, then quench in oil for rock-hard strength. After tempering, they tumble in a zinc bath for corrosion resistance, emerging with a bright silver coat that laughs at rain and mud. A robotic carousel gauges length, hardness, and pull-out force. Anything under spec is binned for recycling back to the melt shop. Approved pins snap into blister trays, slide down a chute, and drop straight into printed boxes, ready for farms worldwide.